Hello everyone. Today's problem we're going to solve with machine learning is predicting high performing dishes for small restaurants using machine learning. So the problem is small restaurants often struggle to identify which menu items are truly high performing. This can be due to limited data analysis capabilities, leading to missed revenue, opportunities in the long run, and inefficient menu decisions. Some of the background research. The restaurant industry is highly competitive and low margin. According to a 2023 report by Toast Incorporated, the average restaurant profit margins range from 3% to 5%, with around 60% of new restaurants failing within their first year. So some of the opportunities for machine learning. Restaurants already collect lots of data, such as sales, costs, customer feedback. This can all be used to make smarter menu decisions. Machine learning can find hidden patterns in complex factors like seasonality, what time of day or month people come in, and this can influence pricing, which people can often misinterpret. So machine learning makes it more accurate. Automating dish performance and predictions save time and help the restaurant staff focus on delivering profit and better customer service. So on opportunity evaluation, I have 3 stages. The first is defining the problem. So small restaurants often rely on guesswork or simple sales counts to decide which dishes to keep on their menu. This can often lead to missed opportunities and wasted resources. So define success is the second point. Success means accurately predicting which dishes will perform well so restaurants can boost their profitability, reduce waste, and improve customer satisfaction. The third point is identifying relevant factors. Key factors include historical sales data, the cost for preparing dishes, customer reviews, seasonality changes, and pricing. So let's move to the CRISP DM business to really understand the problem. So problem definition. The goal is to predict high-performing dishes using historical sales data, as well as to calculate costs and analyze feedback data using historical data of dishes, also the cost of ingredients, the times it takes to prepare the dishes, and customer feedback. The model will classify dishes in 3 segments. The first is keep, where the dishes are kept on the menu. Promote is when dishes are moving fast and they're promoted. Or remove, where the dishes are removed. So what defines success? The outcome metric, increased revenue or gross margin by selecting the right mix of dishes. This can boost the profitability of the organization and the restaurant. The output metric could be like the accuracy or the F1 score and can be used for dish classification models, which can in turn increase the revenue or gross margin, and also select the right dishes which can be placed on the menu and also those that can boost profitability. Additional key performance indicators. So those could be like lower kitchen prep times. So in brackets I put by removing complex underperforming dishes. So dishes that are not performing well are removed from the menu, and dishes that are performing well are kept on the menu. Some are promoted, some are kept, and that can also be based on improvement in customer satisfaction scores. So the higher the score, the more popular the dishes, the lower the bad reviews. Most of the dishes are taken out of the menu. Also, we have like relevant features. So the dish price, the ingredients cost, and then the time it takes to prep the dishes. Also the order frequency, how many times something has been ordered, the day and the time, how much is being sold, which customers are rating which products, what are the classifications of the rating and the dishes. Then we talk about the solution validation plan. So there's a solution concept which says you're trying to build a model like a classification machine learning model which predicts if the dish should be kept, promoted, or removed from a restaurant. So the validation plan goes like this. First, train the model using past data or historical data to capture patterns of dish performance. Perform additional tests on recent data for accuracy and then compare it to like most recent sales and feedback data to evaluate its accuracy. Also conduct feedback sessions with restaurant owners to gather real-world insights on their products, and also improve the process iteratively. And this can be done by incorporating both data updates and user feedback. So the machine learning system designs and the decisions that I've taken, which would benefit this kind of model. So for the model, in the first point, I would recommend a cloud-based solution because it can handle large data sets, complex processing, and provide easy updates without needing on-site hardware. The second point I would recommend is offline learning, since the model is trained periodically on vast amounts of historical data rather than continuously updating in real time. This can reduce the complexity and is sufficient for many decision cycles. And the third point I would suggest is using batch processing because dish performance is evaluated on a weekly or monthly basis due to amount and volume of the data required. So rather than doing instant prediction for each order, I would say that batch processing is simpler and more cost effective in the long run. So the risks and production challenges. What are the anticipated risks and issues? So first we'll talk about data drift. So as time goes by, the customers may change their taste. They may prefer a certain food or another food. It can also be used in different aspects. For example, in holidays, based on the season, the different trends, people prefer different kinds of foods. So this may cause the model's prediction to become less accurate if not regularly retrained with fresh data or previous data based on specific seasons or specific holidays or trends. For the second point, the cold start problem, new dishes lack data, so this means there won't be enough data for the model. So in order to fix this issue, it can be managed by using manual tags, expert rules, or similar dish comparisons. So this can be done until enough data is accumulated in order for the new dishes to be analyzed or trained. Then we have the training skew, which is pre-processing steps, which must be consistent in both phases. So there are no differences between data that's pre-processed and data that's in real time. So we want to like reduce the skew and see how more accurate the data becomes. The last point is external factors. So these could be like factors that influence, for example, like the shift in pricing, the market trends, the availability of ingredients, the competitors. Some of them can like change. There can be like changes in dishes. There could be like location factors, demographics. All these could be like risks and production challenges that could affect the overall model. So from this, you have seen how a problem can be solved using a machine learning and what are some of the risks that we brought up, then some of the mitigation measures as well as some of the architectural types that we can use when choosing a machine learning model.